work. We have this definite integral we want to evaluate. Now your limits of integration and your exponent here will probably be different from mine, but the process is going to be pretty much the same. So I've got cosine over sine squared of z. And since we've got an exponent on the sine and cosine is the derivative of sine, our best choice for u is going to be sine of z. So du will be the derivative of sine is cosine of z dz. Now if we want to solve for dz, we'll divide both signs by cosine of z. So we'll get dz equals 1 over cosine z times du. Now let's go back and substitute some stuff back into our original integral. So for now we'll keep cosine of z on the top, and on the bottom, since we had sine squared of z and our u is sine of z, we're going to have u squared. And then substituting in for dz, we're going to have 1 over cosine of z times du. Now our cosine of z's cancel, and we're just left with the integral of 1 over u squared du, and we can rewrite that as the integral of u to the negative 2 du. Alright, so let's rewrite a little bit of what we had before, just to keep it in front of us. So this is our original integral we started with. We substituted u equals sine of z, and this is where we are now. We've got the integral of u to the negative 2 du. Now we need to look at our limits of integration, because those are going to change when we switch from z to u. So we had, for our lower limit, z was pi over 4, and the upper limit, z is pi over 3. Now when we switch over to u, u is sine of z, so for the lower limit we're going to have sine of pi over 4, which is 1 over square root 2. So I'll just write that in over here. And for the upper limit, we have u is the sine of pi over 3, which is root 3 over 2. So we'll write that over here. So now we've got all of our U-substitution done, and this is our new integral. And to evaluate, we're just going to use the power rule. So we integrate u to the negative 2. We're going to add 1 to the power and get u to the negative 1 times negative 1. So we'll just have a minus out front there. And our limits of integration are 1 over root 2 to root 3 over 2. And now I just plug everything in. So I'm going to get negative root 3 over 2 to the negative 1. Now I'm subtracting a negative, so I'm going to add 1 over root 2 to the negative 1. And a little simplification gives us negative 2 over root 3 plus root 2. And that's our final answer.